Okay, today we're talking about a particular type of function called the piecewise functions, and sometimes that can be called the step function. So let's look at our objective here. We are going to graph and evaluate step and piecewise functions. Okay, so the definition of a piecewise function is they are functions that are defined by different equations for different intervals of its domain. Okay, so what it is your function is split into different sections. That's all it is. Okay, so we'll start by graphing it. Oh, whoops. So here is typically what a piecewise function looks like. So it's a function, we call this f of x, and it has a big bracket, meaning that f of x is equal to all these things. So in the bracket here, we have different types of equation. And I want you guys to think of this as like all the orange one is a separate thing, and the yellow ones are separate, and the red ones are separate. They're all part of that function, but they only take place in their own section. Okay, so what I mean by that is if you look at this orange part here where it says if x is less than or equal to -3, that basically split your graph into a section by itself. Okay, so the orange section is from -3 and all the way to the left because it says x is less than -3. So what it means is when I am in this section, I'm going to graph the 2x. That's my function. Okay, so that's one section of the graph. And the next section would be between -3 and 2. So that's my yellow section here. So I'm just basically shading this so you guys can see what it looks like. But when you're graphing it yourself, you don't have to shade anything. Just know that your graph is split into different parts. That's all. Okay, and the next section is when x is larger than or equal to 2. So it's from 2 all the way to the right, right? That's my red section. Okay. So let's see how to graph this, right? So first I want to graph the orange part. So the orange part is 2x, so it's easy. It's just a line that goes through 0, 0, and the slope is 2. So that's my line. However, it should only happen in the orange section. So the x is less than or equal to -3. So in that section, I only take this part of the graph. Okay, you see the blinking part. That is the one I keep. So the other part is outside of my orange section. It should disappear. Okay, so it's gone. Now, I put a solid dot here because the boundary is equal to, so it includes the endpoint. Okay, so I have a solid dot. Now, I go to my next one in the yellow area, and I graph this line. This line is -x plus 5, so you start at 5, right? And then the slope is -1, so it goes down like that. But your graph only appears in the yellow section, so between -3 and 2. Okay, so between -3 and 2, it stays. So you guys see that? Oof, crazy white background. That should not have happened. But in this section, you keep that graph, and the other parts disappear. So here I put an open dot because there's no equal sign here. So there's an open dot here. I don't know why my other open dot didn't show up, but I should have had another open dot here because there's no equal sign there. So open dot here. Okay, I just know that it should be there, but it's not. And then I'm going to graph the last one in the red section. So, oh, there it is. Okay, now the red section, I graph this line. So in this red section, I graph this line. F of x is equal to 3, so the line is just straight across. And because I am in the red section where x is larger than -2 or +2, larger than or equal to +2, I only keep this part of the graph. And then this part has to disappear. Okay, so there is my final function. That's what it looks like. The graph of the function looks like that, right? So the orange part, oops, the orange part is this line. I only keep the part in orange. And the yellow part is this line. I keep in the yellow part. And the red part is in here, this line. All right, so let's try to evaluate based on this this function here. So they might give you the function, they might give you the graph, they might give you both. But what they want you to do is to evaluate something. So what is f of 3? So when they give you f of 3, they're basically saying x is 3. What is y? So when x is 3, so you want to look at the graph. When x is 3, what is y? Right here. So you go to this point, x is 3, y is also 3 at this point. You can do that by looking at the function. So f of 3, when x is 3, so here you can't use this, right? Because here it says x is less than negative 3, but you have 3, so it's not less than negative 3. 3 is not between negative 3 and 2, so you can't use that, but you have to use this one. So think about x is 3, you have to use the red one because x is larger than 2, so it has to be equal to 3. So f of x, or f of 3 is equal to 3. Let's do another. What's happening? Okay, so f of 0 is when x is 0. So I go to 0. What is f of x? It's 5, right? If they don't give you the graph, you have to think 0. When x is 0, which one do I use? 0, is that less than negative 3? No. Is it between negative 3 and 2? Yes. So I have to use this equation, negative x plus 5. So I have, yeah, so you use the yellow one. So f of 0 is negative 0 plus 5 because I have to use this one. Which gives you f of x equals 5, which matches your graph, which is what you want. And the last one here, they give you f of x is equal to negative 10. They're basically saying y is negative 10. What is x? So you go to y is negative 10 right here. Oh, there it is. And then you look across, right? Where is my equation? So there it is. So you look to see, oh, it hits the graph right there at that point. See? And then you're like, oh, it's this point. What is x? X is negative 5. Okay. So that's the idea about piecewise function. I think you guys got to try it, do the homework, and then we'll talk more in class. Here's an example of what's oh, x is equal to negative 5. Example of what a step function looks like. Okay, it's just a piecewise function where the intervals are split so that it's equal, and then your equations are all flat. So it looks like a bunch of steps. You guys see, you step here, then you step here, you step. So these are step. They look like a set of steps, right? So that's why they call it step function. Here's another example. Okay, like these. And if you want to read more about this, check out page 87. There's figure 39 to tell you more about it. But step function is just a piecewise function. That's all.